Alright, we proceed. The next thing is we have a graphing a polynomial function, as we have seen in the board. First, plot point to determine the shape of the graph of turning point. You have to plot point to determine the shape of the turning point. Then connect the point with a smooth continuous curve and use the idea of end behavior to sketch the graph. So what I'm trying to say, we have treated how to plot a graphic function, the sketch, not plot. So by this type, we have to use a table of values to plot some points on the graphic paper and then join them to be able to get the curve. So in this case, the first thing to do when you are given a graph to point is first plot point to determine the shape of the graph. You have to plot point to determine the shapes of the graphs of the turning point. So you have to plot point to determine the point of the turning point. So if you are given g of x, are you seeing the g of x equal to s raised to power 3 plus x plus 3, and the second g of x, it must not always be f of s, g of x, s raised to power 5 minus 3 s raised to power 4 plus 2, are you seeing it? 2x minus 4 and lastly g of x, here g of x is equals to s raised to power 4 2s raised to power 3, this is 3, plus 3x. So plot first thing you have to do is to plot point to determine the shape of the graphs of the turning point. So these are functions you given to plot the graph. So I just want to make some reference of the use of table of values, that is assigning some values of x and then finding the value of g of x. Use the assigned values of x to plot the graph. So let's do the first one. Form table of value of x and g of x. In this case, we are treating g of x. So we make the table. You know how to make the table. F of s. So the first one, that is g of x, equals to s raised to power 3 plus x plus 3x. So we proceed. How do we find the value of the function g of x? It must always be equal to the function. So let me find some intervals of x from -2 minus 1, 0, 1 and 2. That is interval x, minus, I want to use the values to plot the graph of g of s equals to s raised to the power 3 minus x plus 3. That is minus 2 is less than or equal to x. This interval, and s is less than or equal to what? 2. So this is interval I want here, minus 2, minus 1, 0, 1 and 2. So when s is minus 2, y is what? Copy this thing out, pause now, copy it out, so I can clean the board and make some illustration. So we can proceed. So when x, this one, when s is equals to minus 2, the function g of x will be equal to what? Minus 2 raised to the power 3 plus minus 2 plus 3. So when s is equals to minus 2, g of x will be equal to what? Our g of x will be equal to, this is 8, minus 8 minus 8 minus 2 will give us minus 10, minus 10 plus 3 will give us minus 7. So this is minus 7. So proceed. We have found the first one. So the second, when x is equals to minus 1, do you see the function? If you have copied it out, this is the one you will do. Do this one, this string, I've cleaned it. The function is g of x. We are trying to find the table of value for this function, s raised to the power 3, s plus 3, this function. So when s is minus 1, g of x will be equals to what? Minus 1 raised to the power 3 plus, in bracket, minus 1 plus 3. So minus 1 raised to the power 3 will give us minus 1, minus 1 will give us minus 4, minus 4 plus 3, minus 4 plus 3 is what? Minus 1 minus 1 will give us minus 2, minus 2 plus 3 will give us 1. So this is 1. I hope you are following. The third is when s is equals to 0. If s is equals to 0, g of s is equals to what? 0 raised to the power cube 0 plus 3. That gives us 3. So here is 3. That will give us what? 3. So we continue. I'm trying to get the table of value. So when s is equals to 1, g of x is equals to what? 1 raised to the power 3 plus 1 plus 3. 1 plus 1 is 2. 2 plus 3 is 5. So this is 5. I first make an interval for x so that the intervals will seem like cluster, be together. From there I can find the value of g of x. With the value of s and the g of s, I can plot the graph. So when s is 2, g of x is what? 2 raised to the power 3 plus 2 plus 3. 8 plus 2 will give us 10 plus 3. That gives us 13. So that gives us 13. So we proceed. Having gotten the values, we can now proceed. You have any question on how we got the values of s and y? I can now clean the board and draw the graph. We have already known how the graph with the values we got Any question? Let me bring this table of values up. Table of values of x and the g of x. When g of x is equals to what? When g of x is equals to s raised to power 3 plus 3 plus x plus what? 3. So I hope you are following. So I can now bring the graph up. Table of value. This is s, g of x, minus 2, minus 1, 0, 1, 2. This gives us 7, minus 7, 1, 3, 5, and 13. Have any question? So the table of values looks like this. So we can plot the graph, although if you have a graph paper, this is how it's going to be. So any question? So the graph will look like this. This is why is likely to be g of x. G of x, and here is x. So if we assume here is 5, and somewhere here we have 13, so we have here minus 2. I hope you are seeing it. Somewhere here we have 5, we have 10, and in between we have 13. So 0 up to minus 10, minus 5. So we can proceed. Are you seeing the value? When s is minus 2, y is what? Minus 7. Here is 5. Here is minus 5, minus 7, and so on, and minus 8. So when s, you can always, when s is minus 2, y is minus 7, so you can track it here. They will meet here. This is where they meet. When s is minus 1, so we are here minus 1, y is 1, is 1 here. They will meet here. When s is 0, y is 3, s is 0 on these axis. So somewhere here we have 3. I hope you are seeing it. This is 1, 3 somewhere here. So when s is 0, y is 3, they will meet here. So at 3 they will meet there. When s is 1, somewhere here 1, y is 5. You can track it somewhere here 5. No, you use graph paper. And finally, when s is 2, if we say somewhere here 2, y is 13. Let me make little adjustment. Say 2 here. So when s is 2, y is 13. They will meet somewhere here. So with this knowledge, we can use a curve, a smooth curve. It is now joined. This is how the curve will look like. Visit the website. I gave you the website. Plot this graph there, the graph of this. You will see it will look like this, as if it's coming down. Enter here and continue to go down. So this is how it will looks like. Sorry. So the graph will look like this, pointing at arrow. So if you try to find a turning point, you will see that the value of s is imaginary. We give you an imaginary number. We suggest the turning point doesn't actually occur. So the graphs will look like this. But looking at it very well, you see that it's a cubic function, a graph of cubic function. This is a function of g of x equals to s raised to power 3 plus s plus 3. So can we proceed? Please do this one. Do it if you have any question. You ask me. Let's say I provide a solution for you. f of x is equals to 4s minus 9 minus s raised to power 3. Do it quickly. If you have any question, then I'll provide the answer for you. Can we proceed? We are coming to an end of the lesson. Sketch a graph of polynomial function f having these characteristics. Sketch a graph of what? Polynomial. Sketch a graph of polynomial function f having these characteristics. Having these Are you seeing it? F is decreasing when s is less than minus 1.5. F is decreasing when s is less than minus 1.5. F is decreasing when s is less than minus 1.5 and f, sorry, this is not f, this is x greater than 2.5. F is increasing. Please get this question because immediately I finish writing, I clean the board and plot the graph. We can now call it a day. If you have any question, ask, then I'll provide the solution for you. S is 2.5. F is increasing when minus 1.5 is less than s. S is less than 2.5. and f of x is greater than 0 when s is less than -3 and 1 is less than s is less than 4. F of x is less than 0 when -3 is less than s is less than 1, and s is less than 4. Use the graph to describe the degree and leading coefficients of f. And leading coefficients of f. Go through the question before I will proceed. Sketch a graph of polynomial function having these characteristics. F is decreasing when s is less than -1.5. This is one of the given value. S is also greater than 2.5. F is increasing when -1.5 is less than s is less than 2.5. 2 point given. F of s is greater than 0 when s is less than -3. In this case, 1 is less than s is less than 4. Also, you are given that f of s is less than 0 when -3 is less than s is less than 1, and s is less than 4. Use the graph to describe the degree and the leading coefficients of f. If you have gotten the solution, the equation, you can write the equation down so that we proceed. So the first thing is the steps. Step 1, since f is decreasing, f decreasing, this is the first step. F decreasing for x, because s is an element of negative infinity -1.5 when its union with what? 2.5 positive infinity. These are a range of these given values we are given. So the first step is to analyze the word problems involving algebraic function of a polynomial nature. So the first thing is a function. S is element of negative infinity, from negative infinity to negative 0.5. This union is with 2.5 and also with positive infinity. So if f increasing, when f is increasing, the function is increasing for x, element of negative 1.5, 2.5. So at this case, f of x is greater than 0 for x, element of negative infinity, -3, where its union with what? 1 and 4. These are values given. If you read the question very well, it's another values given, 1 and 4. And lastly, f of x when it's less than 0, f of x less than 0 for what? X, element of what? Element of -3, 1, when its union, this is a union symbol, 4, infinity, positive infinity. These are values given. So analyzing these values using a set notation, we can now we can plot the graph based on the values of s given. So can I clean the board? Can we proceed? I can clean the board. So we graph the function. Considering the values given. Considering the values of x given, values of x that is given, -3, -1.5, 1, 2.5, and 4. These are values given. So we can draw the graph, how the graph is going to look like. So we can choose the, here is 0, -1, -2, -3, -4. Here is 1, 2, 3, 4. You can extend it. 5. So here is what, 10, 20. Here is -10. And here is -20. So based on the values given, we can, the first value is -1.5, somewhere here s. When s is -1.5, we say that it is what decreasing. So we can do it is slightly curve here and proceed to cut here. The curve continue. This is not s. It will looks like this. This is how it's going to look. We plot this based on the values given. You see that all the values, the graph passes, or the values are used to plot the graph. The turning point is slightly somewhere here. You can confirm this graph. Visit the website I gave you. You can still confirm it, plot it there, and somewhere here, and then actually no, remove this value. So this is how the graph's going to looks like. So having arrived at this point, the next thing is to use the properties of what I told you earlier to describe this graph. Behavior, the end behaviors of the end behaviors of the function using the degree and the leading coefficients. So we can describe this graph. We proceed the degree. The degree, because of this, see how the graphs look like. The degree is odd. It is odd, and the leading coefficients is negative. the leading coefficients of this graph is negative based on here. The leading coefficients is negative. For such reason, the f of x, the function, will tend toward negative infinity. Will approaches negative infinity as s approaches what? Positive infinity. And at this point, f of x will approach what? Positive infinity as s approaches what? Negative infinity, because here. So this is how the graphs sketch a graph of polynomial function having these characteristics. You can visit the characteristic again. I have cleaned it. So this is how the graph going to look like based on the values of s we are given. From there we can analyze the when it is decreasing and then begin to increase, and the values of the functions of f of s at any given interval. So this is where we stop. Do you have any question? You can now ask your questions so you can get a response. Please do other homework in the books, book given to you. And if you have any question, please ask me. I will provide the solution for you. We will proceed in the next topic, possible chapter 3. The word problem leading to algebraic, that is polynomial function. You can do them. It is not much, so that we can proceed to chapter 3. See you soon. Bye.